Okay, so we see that we can find the equation of a line using the slope-intercept form, y equals mx plus b. And this is a fantastic tool because it always works and it allows us to quickly find the equation for a line. Great. But you know what? There's even a faster way in some cases, and I want to tell you about that method. This is called the point-slope form. Now, point-slope form has got to be the greatest way to write a line. This is my favorite way. And here's point-slope form. Point-slope form is a form where you're given a point and the slope, hence its name, point-slope form. You see, this wasn't thought of out of thin air. People spent months upon months thinking of the appropriate name. This is the general form of point-slope form for a line, and let me tell you all the characters here. Well, m you've already met. M is the slope of the line. And then this point here, which looks just like sort of x and y, but they're not. In fact, this is just a particular point on the line. So that's a particular point that's actually on the line. Now, let's think about this. So if I just have the slope and a point that's on the line, I should be able to determine that line uniquely. And let's think about that for a second, because remember what we talked about some time ago, that slope just tells me pitch, so there I get the pitch down. But then, of course, there's a lot of ways that that pitch could play out. But if I had a point that I know it goes through, that will solidify the line for sure. So if I just know a point and I know the slope, I should be able to report the equation. And here's the formula. Now, where does that come from? Well, if you think about it, slope is just change in y over change in x. So what I know is that slope will have to equal the change in y over the change in x. And if you just multiply both sides by x minus x1, just multiply both sides by this, look what you see. You see exactly this. Because when I multiply on this side by x minus x1, they cancel. And when I multiply this side by x minus x1, I get this. So in fact, this just comes from literally the very definition of slope. There's nothing to remember here. Just remember that slope equals the change in y divided by the change in x. But the power of this is absolutely amazing. Suppose that I tell you that I'm thinking of a line, and it passes through the point minus 1, 3, and it has slope equal to minus 1/4. What's the line? Turns out this is absolutely no big deal if you use point-slope form, because all I do is report this into the formula, where this is x1, this is y1, and this is the slope. So what I would see is y minus y1, which is 3, equals the slope, minus 1/4, times x minus x1. Now, that's a minus 1, but a minus and a minus combine to give a plus 1. So notice I just plugged in the minus 1 here, x minus minus 1, x plus 1, and I plugged a 3 into here, that's y minus 3, the slope into here, and all of a sudden, this is the equation for that line. Look how easy that was. That really was easy. I didn't have to find the y-intercept at all. Okay? Let's go backwards. Suppose I tell you I'm thinking of a line. I'm thinking of a line, and it looks like this. Oops. 2 over 3. X plus 1. What can you tell me about that line? Well, you can tell me a lot of stuff about that line. For example, you can immediately tell me the slope. The slope is 2/3. And in fact, you can tell me a point that that line must pass through. Namely, well, you have to be careful. This plus 1 doesn't quite fit this formula, so I have to write this as 2/3 times x minus minus 1. It always has to be in the form x minus the value. So here I'd see minus 1 comma 2 is a point that the line contains. So the slope of this line is 2/3, and it passes through the point minus 1, 2. So in fact, we could actually give a very quick sketch of the graph of this, just given the formula. Let's see how this would go. So I know that this thing passes through minus 1, 2. So I go minus 1 in the x direction and 2 up. So I know it passes through that point, and its slope is 2/3. That means I go 3 units over and 2 units up. So 1, 2, 3 units over, 1, 2 units up. There's another point on the line. There's an extremely accurate graph of the line just given this equation in point-slope form. So it's really a fantastic form to write a line in if you're just given any old point and you're just given a slope. No problem. It is by far my favorite way to write lines. I even like it better than slope-intercept form, even though slope-intercept form was the thing I grew up with. When I was a kid, that's all they were teaching, slope-intercept form, and I loved it because y equals mx plus b. It sounds so good. But when you start thinking about it, and if you were to go on to calculus, boy, point-slope form, definitely the way to go. So buy some point-slope form futures now.